Hey everyone, my name is Jun Cho. I'm from a company called Dialectica. We are an educational social technology company. Fundamentally, our issue is with context. What we notice is that in the transition that appears to have been taking place within social over the past 10 years or so, there's a movement towards adding additional forms and modes of context. What we see in next generation feed technology specifically is that people add ephemeral context with Snapchat, for instance, hashtag context with Twitter. This represents a new kind of like a treatment of this one-dimensional feed interface that we've all been working with since like, geez, the 80s. We have something different. We're just tired of working with feeds. This is Dissent. It's a debate interface currently in testing with several, actually, kids from low-income high schools from Oakland. We have done no marketing, no advertising, and it is essentially a fully built debate platform with an AngularJS. We map not only time in a vertical dimension just like feeds do, we also map what's off of what or what's responding to what. This is a philosophical quantity known as intentionality. It's a very general, directed, it's a very general concept of directness. Connotation, association, anything can be intentionality as long as it ties two discrete philosophical objects together. This solves a lot of fundamental problems in the feed format as well as social, chat, and collaboration. What's interesting about this specifically is that this is a very intuitive format for high school debaters and college debaters. If you've ever debated in an academic setting, this will be immediately intuitive to you. They use 1 to 30 ratings, and they'll often assign 1 to 30 ratings, say, per argument. So we can have very intuitive exercise where we just give 1 to 30 ratings in an argument. Now, the beauty of this is, and the way that these things are structured is column 1 is speech 1, then the negative, that's the affirmative. The negative gets up for speech 2, that's column 2. The affirmative gets back up and answers in speech 3. And so we get a series of averages for how this third person rated these two sides. This gives us an incredibly fine-grained, very specific number for how this person feels about issue X or issue Y. This is significant for debate. It basically kills debate. It solves a lot of basic problems in academic debate, and it's a huge weapon for about 165,000 academic debaters who are not being served for this pain point. More specifically, though, and more interestingly, it is also an incredibly crucial and valuable commodity in politics. I can not only tell you how Democratic and how Republican a person is, I can tell you what they're Democratic on, how Democratic they are on that subject, how liberal they are, how progressive they are, and how it rings, sheerly by extending the feed into multiple dimensions. We can also do interesting things with K-complexity. We can automate large portions of customer conversations, sales conversations, and indeed a lot of stuff like litigation and legal contracts. We are able to identify, by means of, again, looking at these very simple ratings, and these don't have to be judge ratings, it could be any arbitrarily identified quantity within one of these argument boxes. All of these things have a certain K-complexity signature. This, in actual conversations, means that you'll be able to identify difficult conversations, complex conversations, automatically. This is a screenshot straight out of Mixpanel. We have nothing to hide. We have intensely addicted users to an alpha product. We've done no advertising, no marketing, there's no manual, there's no FAQ. We haven't even told that many people about it. We have kids on this product up to 7 hours a day, 2 to 3 hours a day on weekends. This is all text. It's basically a homework program. We haven't even added images yet, and people are intensely addicted to this format. Why? Because we've hit on something really specific about how people want to have conversations online. This is our segmentation graph, straight out of analytics. We've done no advertising, and people are on our product not because of our marketing, but because they're addicted to it, and we're solving a problem that they aren't getting anywhere else. This is our business model. It's fairly simple. We get people to go onto our system, we get data from them, we get context analytics from that data, we use those context analytics to build incredibly fine-grained advertising, and then we get more users. This is why this makes business sense. In 19 months, the way that you, me, and everyone else in this room thinks about debate will be completely cognitively and socially different. In other words, debate's going to get really fashionable and cool in about 18 months, 19 months. We are one of the only companies in the world, actually, that's pre-positioning a debate-specific interface specifically for this event. Remember, we get incredibly fine-grained, valuable political data. We estimate it's going to be $1 billion data hit sometime around August 2016. This is us. We are in testing with low-income urban debate league students from Skyline and Oakland Tech High School. In fact, I just came from Skyline High School before coming here. Our advisors include people from social entrepreneurship funds, the 173rd Airborne. My co-founder is from the Stryker Brigade in Washington. We are politically diverse, we are ethnically diverse, and we are also highly culturally diverse. We're a company founded on a dialectic. And we are looking for a d3.js programmer to unjankify our Angular.js project. This is a couple of links to some of our demos and our debates. My Facebook wall, which is facebook.com/showjune, is like clotted up with like all these high school kids having debates on my Facebook wall. Our interface can be seen in detail on Project Transparency, and Rap Game Too Strong are some of our kids having a debate on the history of hip hop. So that's us. Go ahead and email me if you have any questions or you'd like to find out more. And we are interested, as I said, in finding co-founders as well as people who work on our product. Thanks.
Before I started working at Stanford, I worked at a company that made visualizations for finance companies. So I learned D3 doing bar charts, line charts over and over, pouring through Mike Bostock tutorials and figuring out how to change little pixels, but really not exploring different paradigms of visualization. So working with genetics data has kind of given me a chance to go back to the drawing board and kind of work with data that doesn't come from humans, comes from nature. So it's kind of a little get a chance to kind of do some unconventional visualizations. So before I'll show you, this isn't made with D3. This is a page that am working on replacing with D3. So this shows a genetic alignment of a gene across a couple different strains of the same species of yeast. And the vast majority, I'm not trying to pick too hard on this because this is really old. The vast majority of the screen real estate is showing the portions of the sequence which are identical, which isn't very interesting to biologists. They're more interested in the parts that are not totally identical, which are the variant parts. So here's a D3 kind of way to explore this data. So these are going across, these are a bunch of genes, and these are a few strains. So it's cool. Our API we're still working on this feature, so the API isn't returning all the genes, but usually you can scroll through the whole genome and this keeps filling in. But right now we'll just focus on the first one that I'm looking at. So if you click on this gene, you get this kind of abstract view that shows you kind of where the gene is and these lollipops which represent where the variants fall. And now if you hover over these, you only see the portion of the sequence which is varied. So you see these huge chunks which in the kind of old version of the display would take up all the real estate are hidden. And our attention is drawn to these portions which are different, which is hopefully making this data a little easier to look at. Everything I'm working on, I'm trying to open source. So I want to draw everyone's attention to this project, which I think is really cool, called BioJS, which is a project maintained by the EBI, which is the European Bioinformatics Institute. So it's just a bunch of JavaScript components which are useful for bioinformatics. Some of them are data visualization, some of them are more analytical. But if you're either in the camp of somebody who's trying to learn D3 and wants to do something a little different, or you're really good at D3 and you want to flex your muscles, or you're jaded with the technology scene and want to work, help scientists do their thing, I encourage you to check out this page. You can see here in the registry some of the components which are available. But if you go to the GitHub page, on the issues, there's things that have this wish list tag, so you can see things that people want to do but can't really do, because just like in every other field, there's a huge need for people with the talent to do this. And a lot of these people there aren't that many people who can do this, and a lot of them don't want to work in universities. So that's all I got. Thanks a lot.
So that kind of looks right. So I wanted to show a couple things. This is an old project I did trying to help the people in the Inter-American Development Bank, which is, think of it as the World Bank, but for the Americas, the continent, not the country. And they gave me some data about like all the imports and exports from countries in the Americas, the continent. So I have all the data of how much they have exported. I think back to 20 years or something like that. So that was the task. Like, that's the data, and the task was, okay, who is exporting what to, or how much to each country, to where? So the first approach when you think of those things is, of course, a map. So I started like with a simple thing, and the idea is that you can click on a country and then see who is, or where the money is going to or I'm from. So things here go from and to. the countries in the Americas. That's why we don't have so much affluency here. And it's kind of nice and neat, but it's very difficult to tell much out of that. So, and there are some obvious problems like this one in here. I was too lazy to try to find a way of finding a centroid that actually landed inside the country. So the center of the United States is in Canada, and things like that. So that was the first approach. So, and then I went into the geek mode or the weird mode and started trying to create like another version that can kind of show more information. So this is a little bit complicated, but let's see if I can explain it. The idea is that we can center here in different countries, like the best country in the world. So then we go to Colombia. So all of these things in this side are the imports of Colombia for that year. So we can actually go to a more recent year. I think I have data up to 2008. There we go. And then here are all the exports, okay? So this is the total imports I have. And I'm showing like only the top, I think, 25 countries that are in, that we, Colombia, are importing from. And this is showing that Colombia is importing the most from the US. And then, but in here, it's also tricky because this is saying that how much of what the US is exporting is going to Colombia. So this is the total of info that I have that the US is exporting, and then this is saying how much is actually going there. And then it happens exactly the same on the other side. So it's kind of neat because you can go and see, okay, let's see the US. Who are like the biggest partners in there and how that has changed across the different years. Like Venezuela used to be exporting a lot of things to the US, I guess a lot of oil and things like that. So yeah, it was kind of a neat experiment. I was lacking a lot of extra data. Like I only had data for countries like inside the Americas. So that's why it's not so accurate, but yeah, that was the initial approach in there. And then I have shown this before in some other meetups, and this is changing completely pages. But I wanted to show it here too. So basically this is a couple libraries I released as open source for network visualizations. These are the typical network visualizations when you connect two nodes. And then in academia, we have developed like these community detection algorithms that you guys might know about. So what it's been lacking up to now is that what if I want to compute that in the browser? So this is the first one. And the idea is that you can actually compute that the communities out of the structure of the network directly in the browser. So to try to make sense of that, just think of it as the algorithm is looking at which things are connected the most, and then it's saying like, okay, all of these blue ones should be in the same cluster, okay? That's kind of useful, and I actually use it for a project I was building during that time in Park. Not right now, I'm in Yahoo Labs. So because sometimes you want to recompute the clustering directly in a network that it has been filtered by the user. So all of this is available for you to use. So you just have to go to the blogs, my blogs, John Guerra. And then the second one that builds on top of this is that, okay, say that you have a network which has been already pre-computed the clusters, and then you want to emphasize the difference between those clusters. So I created an algorithm that basically distributes the nodes into different parts of the screen using an algorithm called the group in a box. What that thing does is that it uses a tree map, and then it centers each one of those clusters into that tree map. And again, all of this is running on the browser, so if you combine the two of them and you have any network with a couple lines of code, as you guys can see in here, and actually following the same format that D3 has, then you can add these features that it's quite useful to identify many things, like for instance, that this node is connecting to the other clusters and things like that, and all of this is open source. So that's what I have for today. Any questions, complaints?
Curious, how large a graph you can deal with some of these algorithms, and if the follow-up is, how do you manage performance if you're dealing with a large graph in the browser?
how large do you think is large? Let's not ask the Facebook guy. Say that again?
100,000 nodes, 50,000 nodes?
You cannot draw 50,000 nodes in SVG at least.
Almost draw 50,000.
But you cannot animate it.
Yeah.
That's the thing. So during my projects, I created a whole application that could handle pretty easily, like 2,000, 3,000 nodes, still showing some animations. If you were patient enough, you can draw the 50,000 nodes, and then the SVG will still handle it. The layout algorithm will still do it. The clustering will chuck. So if you have 2,000 nodes, the clustering will take maybe 10 seconds or so. So it's still doable. So, and if you want to go beyond that, then I actually just submitted a paper to the InfoVis conference where I'm proposing some ideas for that look of trying to sampling the network to try to show the most important things. So I hope to get accepted, and then I can share what I'm proposing there. But yes, and then the other thing is that if you try to show a network of 50,000 nodes, it's kind of difficult to make sense of it, like visually. So it's kind of a trade-off. But so the short answer is that this is for small larges, so for less than 1,000 or things like that. The layout, the group in a box will work with bigger ones. The clustering, no. But yeah, around 1,000, 2,000. Any other question?
Since you're giving the talk next week, what are you going to be discussing in addition to this?
Well, it's still up to discussion what we are going to be. So I think that's one of the things we want to define.
Here's the thing. Actually, we can just open this up for a quick group discussion if you guys are up for this. So we can.
All right. Hi, everyone. My name is Matt Adereth. There's another meetup called Papers We Love that's held in San Francisco. It's a monthly thing where people get together and present on various academic papers that they think are interesting. I gave a mini talk a few weeks ago at one, and I did the whole slide deck in D3. It's just one div with a bunch of chained animations. I'm not going to give the whole talk right now. It's posted on YouTube along with all the slides, but I just wanted to show off a little bit of it. So it's based off this paper called The Mode Tree from '93 by these two guys, Minot and Scott. And the idea is that you have some data, and you want to understand where it's densest. You want to understand how that data is distributed. So the thing that we always do is make a histogram. Here's the shittiest possible histogram of a bucket size of 30. And like you can see that when you use different size buckets, you see different details of the data. Here I'm using bucket size 10, and it's sensitive to where you start it, right? If I had done it centered at 0 instead of starting at 0, I get a different histogram. And as we like shrink the bucket sizes, we see different details appear until we get to the smallest one, which is the second shittiest histogram, where you don't really see anything. So what the mode tree tries to do is it gives you a view into every possible bucket width at once, which is pretty cool. And I took the paper and implemented it in D3. And it's based off of this thing called a kernel density estimate. Here's the math. We just, at every point, at every observation, we make a little Gaussian normal distribution and sum them all up. And we have a scaling factor where we can make the Gaussian wider. And when we sum them all up, we get like a fancy smooth histogram, which is kind of cool. And we can use smaller kernel widths or bigger kernel widths and see different details. And one natural thing to do is just look at a bunch of different kernel density estimates with different widths all at once overlaid on top of each other. So this is something that people used to do, and then they didn't like it, and they came up with this thing called the mode tree, which I'm just going to show really quickly, where you start with a really wide kernel density estimate where there's just a single bump, and you follow where the bump moves, and you kind of just trace it out on this graph called the mode tree. And then when a new bump appears, you connect it all up, and you just keep going, keep shrinking, and you get this alternative visualization of your data that shows you a bunch of different features that appear at different kernel widths. So you can see some fine-grained details, some large-scale details, and it's useful. A lot of the data that's used to generate this final visualization is used in some of the more advanced mode detection algorithms, which is why I got into this. So that's it. This is posted. I'll post a link to it on the meetup. But that's it. Thanks.
My name is Ramesh Sampath. I am pretty new to D3. I don't know anything more than a bar chart and a line chart to make in D3, and Axis is too complicated to me. And but I participated in a data hackathon done by Data Canvas, and Ian was there helping us with APIs and how to get data from. And I teamed up with one more person, Kevin Gates, who actually happened to be really good at D3. So my story is about how you could be not so good at D3, but still participate and contribute to a hackathon and actually win a prize. So this is what we did, which is called seeingtheair.com. I happened to get it. So this is visualization of air quality in various cities as a polar chart by every 2 hours. So that's polar chart by every 2 hours localized to that time zone. And all these time zones, and you can click on any one of the charts. It will take you to the next visualization where you can actually see the averages by each day. And then you can also see the highs and lows by temperature. We're trying to compare temperature effect on the air quality. And you can go down and compare in a box plot of different cities. Most of this work is all Kevin Gates' work. So I'm just going to show you this and then show you the data, how I brought in data for this. And then you can certainly filter for some of these things. OK? So now let me go and show you this, what I did, which is probably less interesting, but I'll show you. So what I did is I wrote a script in Python, which basically, let's see, I think, I don't know if that's that's OK. OK. So script in Python, which basically went to the API and pulled in data for each sensor, and then I would pull in data by min, by max, all of this data, and then I built a web server using Python and Flask, which would, when you hit that web server with specific endpoints, it will actually go, and it's all stored in just CSV, no database, nothing, it's just CSV. It'll concatenate all this data from the CSVs, and then do some wrangling with the data, and finally give you data with those quantiles back as a JSON data back into D3, and then the D3 does its magic. So that's the project. It's all open source on GitHub, of course, but yeah, check it out. And yeah, that's just to motivate that even if you don't know D3 fully, you can certainly participate, and there are things you could do that maybe people who are really good at database struggle with, like pulling data from APIs, putting it in a format that's consumable for them, stuff like that. OK? Thanks.
Hi, everybody. My name is Beth Liebert. I do product and design at a company called MapSense. And we are working on releasing a D3-based mapping library and are looking for people to try it out. So I thought this crowd might be interested to see what it's all about. Here's an example. This is one of our tutorials. It takes San Francisco contours. You may recognize this as Twin Peaks. This is every 5 feet. It's a pretty cool data set. And using D3 selections, you're able to have some really cool interactions with not too much code. You can see the code down here. And this is the styling. And here we're classing it by quantile. We're setting the elevations and the colors for that. And then all the interaction is just in these 2 lines here, mouse over and mouse out, that gives us the interaction between the legend and the map that we saw up here. And the nice thing is this is tiled map data, so it lets you work with much bigger data sets. I'll show you a map of the whole world in a second, but here's all of San Francisco now. You might recognize it a little bit better. So we are making an open source library available, as well as open map tiles. that lets you grab the actual data in SVG format and play with it. So for example, here's OpenStreetMap data. This is New York City, and all the buildings are colored by their height just by using a D3 selection on data that's already in OpenStreetMap. So Jerome mentioned working with maps data and OpenStreetMap. We can help with that. I'll show Paris in a second, but this is OpenStreetMap data made available, made clickable. So you can actually get the metadata on the geometries throughout the world. I've zoomed in on Paris here. Just to give you an idea of what you can do with this when you have everything selectable in the client. You can just select roads. So here's all the roads for Paris, for example. If I remove this filter just from the URL, because it's vector tile and not a raster tile, it's all done dynamically. And here's all the data for Paris. And you can style it just using straight up CSS. So that's where I started. As a designer, I was in charge of making the base maps for our product. So I wanted a way to do it a little more simply than just setting every class on every different feature. And for most people, they just kind of want a base map and go, and sometimes they just want it to be based around a certain color theme. It's pretty simple needs. They don't need to twiddle every little thing in most cases. So I wanted to see how simple I could make it. So in this tool, I let you kind of make a new base map by just picking one color if you want, and it kind of makes some design assumptions about what the map should look like. Or if you want to get more and more fine grain, you can just select, just change the land to be a specific color, or get even more detailed and, set the parks to be something. So this is something I just made on my own using JavaScript and our basic kind of map tiles. And then once you have it set the way you want, like this, you press the CSS button, and this is copy and pastable CSS that you can use in your own map projects to get like a good-looking base map in a really visual, fast, interactive way. So this is really just a personal tutorial that I made that I wanted to share. But if you're interested in joining the trusted tester list, we're a few weeks away from full launch. I'd be happy to add you to it. All I need is your email, so come and find me afterwards. Thanks.
So first off, thank you, John. I'm excited to try out the net clustering. I wanted something like that the other day, so I figured I'd trade you. And this is a little tool I made a while ago to choose centroids. So you click anywhere in any country, and it'll just, son of a gun. HDMI. Oh, you switched it. Got it. All right. So this is a little tool I built where just take any D3 thing, and then it does the centroid function, but then you can click on a polygon, and it'll create the centroid for that country, and then you can drag it and move it around. So kind of the idea being, one of the motivations behind this wasn't necessarily to do centroids, but like with a lot of this stuff in D3, we have these automatic tools that let us lay out things for us and do all this nice algorithmic stuff. But when it comes to the last mile of curating or editorializing your graphic, you're kind of left at the mercy of whatever algorithm you're using. So hooking in a little bit of interaction and making it, since all this stuff is data-driven, right? Like all these centroids are just X, Y, and a circle. Hooking it up to the drag behavior is pretty straightforward with D3, and this whole thing is less than 100 lines of code. So I don't know, just throwing that out there.
But again, there is that, then you save the centroids?
Yeah, so the whole centroid list is just like JSON over here. And this is like, some of this is specific to Tributary, like the environment I'm in, like the way I'm saving them, but it's just an array, so you can save it out however you want. Yeah. And the other thing I wanted to show is something I was messing around with. I don't know if you guys saw Sean Allen's Masonic library, D3 Masonic. I was just playing around and like came up with these weird patterns, and every time I redo it, I choose some different parameters. should reset. I'll just go to this one. But anyway, I made a bunch of prints of them in like real life, or paper. So I'm selling these as a fundraiser for the D3 meetup. So $5 each. You can walk home with your very own data-driven piece of art. All right, that's it. Thanks, guys.